Good morning, everybody. Morning. Uh, here's our objective for this topic. Here's our objective for this topic. And I want to talk about why chemical reactions occur. The reactants are going to need, in order to perform a reaction, they're going to need like a couple things. All right. They're going to need energy, a certain amount of energy. They need to have enough energy to react. They're going to need to collide, hit, and they're going to be oriented correctly. All right. And if you look, okay, these two objects, they may hit and not react. All right. They may be hit and be oriented wrong, and they may just not hit. All right. So you need all three of them for them to react at once. All right. So here, if you look at these two squares, they're going to hit with those three things. You can just tell by looking at them. All right. But for sake of argument, these two squares are going to collide. They're dead on. They're going to have enough energy to react, and they're going. Uh, what's the other one? Be oriented correctly. All right, like that. Therefore, you get a reaction. Now, once again, this isn't what goes here. This thing down here, but that's what it there. All right. Now the thing is, once you start to bring in more than two things that need to hit, it becomes really, really statistically improbable that they're going to do this correctly. Reactions with three or more things needed to hit, it just mathematically it becomes improbable. All right. So that's we're mainly concerned with two or more reactants. No, two basically. All right. Now, in this chemical reaction here, you can see that there are four things. All right. And I'm going to show us now. If you look, I know there's going to be more than four of these things in a chamber, but I've got four things that need to come together to make one big thing. And this is going to be very, very, very unlikely for it to happen. So what's going to happen here is the reaction is going to occur in several steps. They're known as elementary reactions. And to give you an idea for some things about what an elementary reaction is or how they need it, here is a proposed mechanism for water. I'm going to go back real quick. I didn't really talk. So this is like, hey, I just put two hydrogen together with one oxygen on them and I make two water molecules. That's what goes on. You know, you've seen it happen. It's an incredible reaction. However, if you were to break this down into steps, here's what it looks like. There's 90 different steps for this to actually happen. It's pretty radical. And I know it happens super fast. However, that's how it kind of breaks. This is a proposed mechanism. And once it kind of gets started, it can go, but it's not um, going to just be one and done kind of thing. Now, this whole thing, these are elementary reactions or elementary steps. Each one is an individual thing where you just have two different things coming together, and this whole thing together makes a mechanism. All right, it's like how it all happens. like this hits this, makes this, you fold kind of like origami, so to speak. Now, I want to talk about this reaction, and particularly like a couple of these. If you'll notice in this reaction, there's a bunch of stuff over here. All these things are not actual products, all right? And even some of the reactants. Oh, that one is. But even some of these reactants are not products, all right? Or reactants. They're known as intermediates. And an intermediate is essentially something that's like a little bit of a go-between for your reaction to occur. All right. You can see this OHO2 is a definite intermediate. So with these hydrogen radicals, oxygen radicals, all right, those are what are known as intermediates. Now, I want to go back to this reaction that we were talking about, and I want to propose a mechanism. All right. My first mechanism is that my first step is that these two things hit together to form that. That's my first step. All right. And I'm going to call this thing D. All right. Now you can tell it's not it's not a product, therefore it's an intermediate. And then I'm going to say the next thing that happens is that these two things are going to hit together to form something else. And then these things come together to form that. This whole thing is C. All right. And now all of these things should add up to the overall reaction. You can tell that B and E are intermediates. All right. And when I add it up, I get this, and I should have done this a little bit differently, but B and D and E are on both sides, so they drop out, and I'm left with my overall reaction. All right. Now, in this thing, to determine the reaction rate or the rate law, the overall reaction to make this has to come from experimental data. Right? That has to come from experimental data. But these things I can look at and use stoichiometry. This, if I double the concentration, that should double the rate. All right, same thing here and that. All right. And just a reminder, these things can come from the overall reaction rate law comes from a data, but the elementary reaction steps come from the steps themselves. All right. Thank you, and I hope you have a good night.